Hi, this is Carolyn Schechter, and I'm going to be talking a little bit about the pyruvate dehydrogenase complex and how we generate acetyl-CoA from pyruvate for the citric acid cycle. The pyruvate dehydrogenase complex is a complex of 3 enzymes that oxidatively decarboxylate pyruvate to acetyl-CoA. Now we know that glycolysis generates 2 pyruvates for each glucose molecule, so this pyruvate dehydrogenase complex is the link between glycolysis and the citric acid cycle. The enzymes in this complex are the pyruvate dehydrogenase component, dihydrolipoyl transacetylase, and dihydrolipoyl dehydrogenase. And we can see this full reaction here. The reaction looks simple, but there's a lot going on in these 3 steps here to get this group here over to CoA. There are 5 coenzymes also involved in this reaction, and the coenzymes are in 2 categorical groups, catalytic and stoichiometric. The catalytic enzymes TPP, lipoic acid, and FAD, and like enzymes, these catalytic coenzymes are not permanently altered in the reaction, but the stoichiometric CoA and NAD+ function as substrates and will be permanently altered in this reaction. Now the reaction proceeds in 3 steps: decarboxylation, oxidation, and transfer of the resultant acetyl group to CoA. In step 1, the decarboxylation, pyruvate combines with the carb anion form of TPP and is then decarboxylated to yield hydroxyethyl TPP. This reaction also gives us CO2. It's the rate-limiting step and is catalyzed by pyruvate dehydrogenase component. Now we can see the carb anion. We have the anion here, and it is creating hydroxyethyl TPP. Now in step 2, the oxidation, the hydroxyl ethyl group attached to TPP is oxidized to form an acetyl group. Simultaneously, the acetyl group is transferred to lipoamide, which is a derivative of our coenzyme lipoic acid. The transfer also results in a thioester bond. Now, this is a high energy bond, and we need this energy to keep the reaction going. The disulfide group of lipoamide is reduced to its disulfhydryl form in this reaction. As we can see, this bond here is breaking. And this is also catalyzed by E1 and yields acetyl lipoamide. And we're back to the carb anion of TPP. Like we said before, it was not permanently altered. Now in step 3, we're forming our acetyl-CoA. So the acetyl group from acetyl lipoamide is transferred to CoA, as we can see here. The enzyme for this reaction is dihydrolipoyl transacetylase, or what we'll be referring to as E2. And the thioester group is preserved, as we can see here. And now we can see our acetyl-CoA has been formed and is ready to enter the citric acid cycle. So that's the 3 steps of forming acetyl-CoA. However, we do need one more step if we want this pyruvate dehydrogenase complex to continue making acetyl-CoA, because we need our disulfide group back in lipoamide. So that 4th step that we're talking about is not directly involved in the formation of acetyl-CoA, but the pyruvate dehydrogenase complex can't perform another cycle until the 4th step is completed. And in this step, dihydrolipoamide is oxidized back into lipoamide. As we can see here, this bond is reforming. So the enzyme involved in this is our 3rd enzyme, dihydrolipoyl dehydrogenase. 2 electrons, we can see here, are transferred to an FAD prosthetic group to create FADH2. Then these 2 electrons will be transferred to NAD+ to form NADH and H+. So now that we have our lipoamide back, we can go back to step 1. We now have this available for step 2, and we can keep going through our pyruvate dehydrogenase complex. Thank you for listening. We have some references, and let me know if you have any questions or comments.